linear equations. So in this section, we are going to be talking about solutions to a system of linear equations in two variables. So what we want to begin with is when we have a solution to two linear equations in two variables. What it means is that we have a point that satisfies both equations. It makes both equations true. So in problems 1 and 2 here, we are asked to determine if the ordered pair is a solution to the system. So for number 1, in order to do that, what we can do is start out with our first equation and plug in our points. So 2 times -3 plus 6 times 5 equals 24. And we get -6 plus 30 equals 24. And we get 24 equals 24. Well, that does in fact make a true statement. However, in order for the ordered pair to be a solution to the system, it must also satisfy the other equations. So we're going to do the same thing. We're going to say -3 plus 5 times 5 is equal to 3. Well, that gives us -3 plus 25 equal to 3. And that gives us 22 equal to 3. And that is not a true statement, which says no. This ordered pair, -3, 5, is not a solution to the given system. So take a moment and try number 2 and see if you can determine, is it a solution or is it not a solution? So to determine if it is or is not a solution, what we want to do is, again, plug in. So 5 times 0 plus 10 times 1/2 is equal to 5. So that gives me 0 plus 5 is equal to 5, or 5 is equal to 5. So yes, we do have a good one. And then we also have to do that in the next one. So 22 times 0 minus 6 times 1/2 is equal to -3. So we get 0 minus 3 is equal to -3. -3 is equal to -3. And yes, 0, 1/2 is a solution to the given system of equations. So now let's talk about the different types of solutions we can have. Okay. So a system of linear equations that represents intersecting lines. Okay. We're really not going to worry about these definitions here. Okay. Now, if the system of linear equations represents parallel lines, then the lines do not intersect and the system has no solution. And if the system of linear equations represents the same line, then all points for both lines satisfy both equations. So the solution has infinitely many solutions. So there are 3 methods for solving systems of linear equations. The first method is graphing. we're really not going to use graphing that much, okay? But if you were to use graphing, we would graph the lines to see where the lines intersect. And that is the solution to the system. If the lines are the same, you have infinite solutions. And if the lines are parallel, you have no solution. Because if our lines are parallel, they don't intersect. There's going to be no ordered pair anywhere in the world that's going to satisfy both equations. So we don't typically use graphing in this course, but it is an option. So this ones that we do use are substitution and elimination, or addition. I like to call addition elimination, because you're eliminating one of the variable parameters. Okay, so the steps for substitution. First, solve one equation for one variable. Then substitute that into the other equation and solve for the second variable. Then substitute back in to solve for the first variable. So, what does that look like? Well, we have these two lines graphed here. So solve by substitution. It does not matter what variable you solve for. One thing that I am going to point out, though, I notice that this y happens to be kind of all by its lonesome. So what I could do is add this y to both sides and add the 26 to both sides. So that gives me 5x plus 26 is equal to y. And now this is where I can take, because y is equal to this 5x plus 26, I can take it and substitute it in for this equation. So we can say 2x plus 3 times 5x plus 26 is equal to 10. So that gives me 2x plus 15x plus 78 is equal to 10. Gives me 17x is equal to negative 68. Gives me x is equal to negative 4. And if you notice where our lines are intersecting, okay? Now that we have that negative 4, we're going to take it and plug it back into one of the equations. It does not matter which one. I'm going to pick the first one just for the fun of it. So 2 times negative 4 plus 3y is equal to 10. That gives me negative 8 plus 3y is equal to 10. That gives me 3y is equal to 18. And y is equal to 6. All right. So I'm going to come back up here now to the addition or elimination method. So when we are doing this, we can write both equations in what's called standard form. Okay, this is standard form. Or sometimes general form, where it's ax plus by equals c. And then we want to create opposite coefficients for one variable and solve for that one variable. And still, whatever variable we solve for, make sure that we plug it back in to get the other variable. Because remember, the solution to any system of linear equations is a point. It has an x value and a y value. So when we look at this one by addition or elimination, one thing that I notice here is that I have a negative y, and here I have a positive y value. So what we could do is take this here and multiply it by 3. And the reason for that is because that's going to allow us to eliminate the y parameter. So that gives us 2x plus 3y is equal to 10. And 15x minus 3y is equal to negative 78. And then the reason why it's called the addition method is because we're going to add these two things together. And the reason why I like to call it the elimination method is because we are eliminating the y term. And you end up with 17x is equal to negative 68, and x is equal to negative 4. And now this time I'm going to plug it into this bottom one. So 5 times negative 4 minus y is equal to negative 26. We get negative 20. Negative 20. Oops, did not erase like I wanted it to. There we go. Minus y is equal to negative 26. Negative y is equal to negative 6. So y is equal to 6. Okay. Now with both of these, this is not the end of either one of these. We cannot leave our answer in x equals and y equals form. Remember, the answer is a point. So our final solution for both of these is going to be the point, negative 4, 6. So remember, the solution to any system of equations is always a point. So come back in the next video and we will work on some examples.